Welcome back to Bold Assumptions, article roundup number 3. This week I decided to do more of a space theme with 2 articles that could somewhat relate to space. The first article by the New York Times is titled The Lost History of One of the World's Strangest Science Experiments. This article outlines the details of a 90s experiment to try and make a man-made environment on Earth. They called this man-made environment Biosphere 2. What it basically was giant glass domes which inside had man-made life ranging from different grass formations, plants, animals, and anything that they felt would be great to make like just a little utopia. The plan for this was to see how well humans could survive in a cultivated environment that got oxygen from its own trees, got water and food from its own sources, and it was meant to help progress space flight and space travel to a point where we could have self-sustaining spaceships. Interestingly enough, I feel like this article was way ahead of its time. With people wanting so bad, to reach the moon, reach Mars, and go to all these different planets, it makes sense for us to have our own cultivated life to keep us there. Because obviously, when you're in Mars or on the moon, you're not going to be able to just deliver oxygen to your spacecraft. You're going to have to somehow derive your own food, water, and nutrients that you need to survive. The initial test had 7 individuals trying to stay within the confines of the geodesic dome for about a month, and it ended very, very badly. Beginning, the idea for the dome started in the 1970s. It took about 10 to 20 years before any substantial structure was built, and then afterwards they decided to put it in the desert, where they would try and model a thriving ecosystem. And the good thing about being in the desert was they had a lot of sunlight to fuel all of the plants, all the solar panels, everything they needed. Reading on, it seems they filled these biospheres with 3,800 species of plants and animals, including hummingbirds, lemur-like primates called bush babies, and all types of different soil, plants, and just any other type of wildlife. A bulk of the life within the biosphere was also microbial, and the purpose for this was to have sustainable sources of energy and different things to help with life processes like decomposition, etc. Where the mission seemed to go wrong was the fact that it surfaced years later that the people who organized the experiment had to make numerous deliveries of various supplies and food because the biosphere was not as sustainable as they thought it would be. Even eventually surfaced that they had engineers install a carbon dioxide scrubber so that the atmosphere of it was all cultivated by humans, not plants and animals and all the rest of the people. Because it was so cloudy in the desert for the first few weeks, it was very hard to grow any sustainable food or keep longevity within the trip. So the people within the study, they actually had to tap into a storage of food hidden underneath in some desolate area in the dome. For this reason, a lot of people called to question the credibility of this experiment, and it eventually failed. Not to mention, later came a huge explosion of oxygen-gulping bacteria, they called it, where basically this bacteria took over most of the biosphere and was eating up all the oxygen. So the crew members, they had so little oxygen to breathe that it almost felt like they were at a huge 14,000 feet elevation. And eventually they just had to end the experiment altogether to give the crew sufficient oxygen. Looking back on this experiment, I feel like we can learn a lot from it. If we ever do plan on doing such an experiment in the future, obviously sunlight needs to be a huge consideration and possible ways to limit such oxygen-gulping bacteria. The good thing about trying out this in space, for example, is the fact that there's always sun in space. It can't get cloudy. Nothing can block your view of the sun unless you're completely away from it. So ideally you would have, in my opinion, you would have a huge spacecraft with a glass area, right? And within this you have your different plants and everything that you need to get sunlight with a giant window facing the sun. And then with this you can have, as much oxygen as you need circulating through the space station and fueling life. Obviously, it's apparent that if we're ever going to want to progress as a species and, branch out to various different planets, this is going to need to be mastered. So the good thing is we have time. We have hundreds, if not thousands of years before it's a serious issue of leaving Earth. So we have time to master this and get good at it. Even though the experiment seemed to end catastrophically in the 90s, I feel like with our newfound, intellect and what we've took away from the study, I feel like it'd be worth retrying. This idea, whether it didn't work on execution or not, it was a very good idea, and it would be very good for possible future space exploration. In an ideal world, you would have different types of ways of combating these oxygen-sucking microbes, and you would have different ways of sustaining energy without clouds or anything getting in the way. Maybe perhaps we need to look into weather systems and all types of different things before going through with such an experiment, but it's definitely worth replicating. Looking back on the experiment, the only things they note that were a huge problem to end with was the fact that there was a lack of breathable air, lack of drinkable water, and a lack of adequate food. Three things which are very fundamental, but in my opinion, easily achievable. These experiments often make me wonder how we've even been able to be so successful with our own spacecrafts that we've accomplished to this day. How were they able to be so successful without, sustainable energy or oxygen coming in? Obviously, we have to send up these capsules full of nutrients and different resources, but it'd be so much easier if we could just get them from the spacecraft itself. Conveniently enough, I found another article which seems to possibly, if not answer, maybe help the problem that this article arose. This article from the Siberian Times, titled "Siberian Scientists Find Bacteria That Could Live on Mars," seems to arise possible solutions to our problem. After a 10-year-long hunt, a unique microorganism referred to as the Daring Wanderer was finally found by Siberian scientists. 10 years ago, the genetic trail was discovered by American scientists. Basically what happened was these scientists came across what appeared to be the DNA of an organism which could produce energy without light or oxygen. Finding such DNA sparked many scientists to, go for a gold rush in a sense for this microorganism because they wanted to figure out where it was. It's because it's so important to be able to produce energy without light or oxygen. Ironically enough, the DNA was also found in the bottom of a South African gold mine. Eventually, the Siberian team searched near the university they were working at and found at the bottom of a spring system this mysterious wonder. They credited their extensive experience with sulfate-reducing bacteria for the reason they found such a rare microorganism. Moving on to practical applications of this, there are infinite in my opinion. It's important to note that more research is obviously going to be needed to be done before we can see these microorganisms making their way to space or even Mars. Thinking progressively though, I see many applications for this within space and even other planet travel. The fact that the microorganism doesn't need oxygen in order to make energy could become very helpful when we're on planets without atmospheres such as Mars. For example, if you were able to, find a decent amount of these microorganisms and have them replicate and populate Mars, you could have energy within, it would take thousands of years or a really long time, but it would be great for the future. With this, I always like to think about, the possibility of us seeding life for millions of years from now. A lot of people like to think, oh, we're just going to go to Mars and do all this stuff and just it's going to be in our lifetime. But the thing is, life, even with us, took millions of years to become us. So it'd be cool if we were able to just, spread life and different microorganisms around different planets and just, we wouldn't see the effects of it, but our ancestors, or not ancestors, our descendants would see the effects of what we did, and perhaps we could have life and different types of evolved creatures on different planets. It'd be really cool in my opinion. This obviously rises the dilemma of us playing God, but in my opinion, in order to see progress happen, sometimes you got to make rash decisions. In all, both articles are more rooted in future progress and effects and different outcomes which we're probably not going to see the extent of in our lifetime. Nevertheless, they're still important, and I hope that the outcomes are as positive as I see them becoming. That's all for this week. It's been Bold Assumptions.